We will include a discussion on volcanoes here just because they played a big role in changing the weather and climate, as we have already seen with the Tobo supervolcano, for example. Throughout the Holocene, obviously they have also been volcanic eruptions and various levels of loading. So this is a record of volcanic surface concentrations, sulfate concentrations in parts per billion derived from H2O4 measurements on GISP2 ice core covering the past 12,000 calendar years. The inset shows an estimate of the sulfate-induced forcing in watts per meter squared. Note that the forcing can be very strong but does not last long, maybe 1 to 2 years. So we already saw the example of Tobo from modeling, where depending on the loading, the size of the eruption and month of the year, the extent of the impact in cooling, precipitation, and the time over which it would last changes. And here we are looking at volcanic sulfate in parts per billion over 12,000 to present. And you can see that coming out of the last glacial maximum, there is one big volcano here, and that happened before the end of the glaciation, beginning of the Holocene. So you can imagine that would have probably also added to the perturbations that happened later on during the Younger Dryas, refreezing and so on. So that again raises the question of whether agriculture was attempted and was part of the hunter-gatherer diet choices already, and whether it was just not viable, and whether it became more viable here. And if it did, then once agriculture and livestock domestication were established, how were the volcanic eruptions affecting life? So we'll look at one table that shows a long list of impacts just in the 9th century. Forcing is of course how the volcanic eruption affects the balance of incoming shortwave and outgoing long wave radiation at the top of the atmosphere. So obviously you expect volcanoes to have a cooling effect by reducing sunlight or scattering sunlight with sulfate aerosols. So they are all negative, with some massive forcing of -12 watts per meter squared here for the big one. These, for example, the net radiative forcing due to global warming right now is of the order of 2 watts per meter squared. That's the additional amount of energy we are trapping because of increased greenhouse gases. So this table is a good example from this paper. In the period of 800 to 874 AD, annals in the Western Europe list 24 years that contained reports of unusual and harsh weather and failure of crops, pestilence in cattle, and widespread famine and plague in human populations. So in general, there are no eruptions of note in the 9th century data extracted from Palmer and Palmer 2002. Okay, so you can see here phenomena recorded in chronicles during various periods as inferred from historic records. So I won't read the years, but it's worth looking at some of the phenomena that were recorded in the chronicles. Pestilence and widespread loss of animals, great loss cattle and other beasts, extremely cold winter, extreme rainfall in the summer led to failure of the harvest and death of cattle. So you have both dry periods, wet periods, cold winters, warm winters, crop losses, pestilence, and so on. Hail flattened crops and pestilence followed. Flooding widespread in 834. A great flood killed 2,347 people in Frisia. Winter very hard. In, let's say here, 843, people ate earth mixed with flour. Famine in Western Gaul, many thousands have died. 845 again, plague. So winter floods, ferocious electrical storms, summer scorchingly hot, excessive heat and general famine. 856-57, so you can see this period is particularly harsh from 855 through about 860. Winter excessively cold and dry, pestilence has killed many. Plague, swollen abscesses, rotting flesh and loss of limbs. Very severe winter, blood red snow, merchants with horse and cart could cross the sea into Venice. So you can see that sea level change was fairly significant. Here, blood rained from the sky, famine and plague, unusually long and hard winter, famine and plague in Gaul and Germany have killed nearly a third of the population. So obviously massive perturbations in terms of climate, volcanic eruptions, and impacts on crops, people, livestock, and so on. The other thing that is argued to be very important for agricultural success, domestication of wild crops for sustainable food production, is the properties that are critical, like the rachises or the stems that bear corn, the grains, cereals, have to have certain properties like non-shattering trait. So this is looking at two types of wheat and barley, and percentage of non-shattering trait. You can see starting 12,000 years ago, all of them went up in percentage of non-shattering trait in the crop, showing successful domestication. They could have been the anthropological view is that wild crops, wild cereals may have been growing around human settlements because human waste would fertilize the soils and make it easier for the crops to grow. And based on these kind of properties, humans would consider them favorable for food, because hunter-gatherers were probably already consuming some cereals in some form. So then they became successful at domesticating them for continued lifestyle in agriculture. Okay, so more recently, lower Yangtze rice got better and better over a couple of thousand years in terms of non-shattering trait, and other rice variety even more recently also got better slightly in terms of increased percentage of non-shattering crops. Over the time, there has been also spread of various species of rice, of potatoes, of peppers, of corn, maize, and so on and so forth. So if you look at varieties here, Indica and Japonica, with some parts of Rufipogon, you can see that 9,000 years ago, Japonica, I don't know how you would say it, is already here with overlapping Rufipogon, and by 4,000 years there is integration and replacement happening in India by 4,500 years ago. Okay. Similarly, if you look at dates, there are Middle Eastern date palms already 7,000 years ago, and the hybridized version, and there is a North African date palm here. This is a Middle Eastern one, and you can see that by 3,000 years ago there is a hybridized Middle Eastern date that appears. Okay, so again the question is whether these were shared, how they got transmitted. Was it a cooperative behavior? Was it militarized conquers? Were they religiously based? If Buddhism was very active and Buddhism went from India to Japan and China, did that bring about exchanges of seeds and cereals and crops and knowledge about them? And how did they adapt to local climate and so on? So lots of questions there. And obviously this also appears in terms of food choices. Looking at before 7,000 years ago and 6,000 to 5,000, 4,000 and 3,000 years, we are looking at West African dietary choices with various land use types. So Niger land delta and floodplain here, altitudes up to 1 kilometer, and some places with altitude up to 1,000 meters and 2,000 meters. And this phase space shows dietary choices or food habits, food gathering, foraging habits in terms of hunting, breeding, and fishing. And you can see that within short distances, starting here mostly from hunting, everything pointing in that direction at various times periods, begin to add hunting and fishing and also some breeding here in the Niger Delta. where water would have been available, and more of breeding happening here as well. And by 4,000 years it spread also here. You can see there is nothing here. It's a little bit of hunting going on here. No evidence here during this period. Reappears around 4,000 years, and you can see changes in the combination of food systems or foraging systems and how they changed by 3,000 years ago. And you know that the greening of Sahara was about to end here and had ended here and here, but the Niger inland delta and floodplain existed throughout. Okay, so these things have to be considered in terms of whether availability of food or food choices and agricultural success or failure, and how they are related to climate and how they are related to social structure and other sociological factors in addition to climate factors. So this environmental determinism is always debated, whether it's really something that drives everything, or does societal complexification begin to affect all these things in a way. So looking at historic and prehistoric population size estimates for human populations, key features are the larger ancestral African population size and the earlier Neolithic growth in the core agricultural areas. Idea is that the European population and West Asian population had a very rapid acceleration of adaptation here. So if you started prior to the Upper Paleolithic, Africa was home to the largest human populations. You can see the log scale here. And the European West Asian population began to take off just at the end of our MIS 6, I think. Yeah. So we are already getting into MIS 5 here. I think you can check the timelines. So Upper Paleolithic, and in Africa, late Middle Stone Age and later Stone Age. Intensification of populations shown by resource use, diet breadth, and geographic range expansion. Long-term growth probably episodic. So we are still way before agriculture here. So you can see that Europe and West Asia is having increasing population, but Sub-Saharan Africa is continuing to grow. And once you get into Neolithic revolution initiating in West Asia, China, India, Egypt, and later in Sub-Saharan Africa, you have a crossover where Europe and West Asian population takes over, and the arid regions of West Africa fall behind as the agricultural revolution, the Neolithic revolution happens. So again, is this related to migrations, human activities, or agriculture? And if agriculture, then was it a favorable climate, or was it favorable innovations, accidental innovations, and so on? So lots of questions remain, but nonetheless these do provide important pointers to how agriculture played a major role at the global scale in the evolution of modern humans. Okay, so let's leave this podcast here, and then we will come back and discuss again what makes us human and what it may have meant in the context of agriculture. I have strong winds and some noise, but hopefully the recording is fine. Okay.